Our speaker is Kat Scott, who you can get her Twitter information right there, K Scott Z. Um, and so she's been a developer advocate, or is the developer advocate for Open Robotics, the makers of the robot operating system, the thing we're all here to hear about, and also the Gazebo simulation platform, which I'd never heard about before, but it looks interesting. The little bit that I've looked into since then. Formerly, she was the analytics lead at Planet Labs and Stratios. I just realized I haven't said that word out loud. Kat, I don't know if you want to help my
No,
pronunciation.
that's fine.
Oh, that's true. Okay, Stratios, and was a co-founder at Tempo Automation and Site Machine. I'm sorry, I'm reading this directly from the slides. But also currently, Catherine serves on the board of the Open Source Hardware Association and has a master's degree in computer science from Columbia. So, all right, welcome, Kat. I'm just going to go ahead and close this, and I guess you can take over as the presenter. I probably have to
Mm,
hit the stop sharing
Yeah,
button.
let me share here. Okay, cool. I think we're cool. Well, why don't I just start with pandering? I was saying earlier, I love Orlando. I used to be a defense contractor in Michigan, and I used to come down there to do work. I think it was the Army Simulation Center. And my favorite memory of Orlando is because I had to show up at the base at like 5 a.m. all the time, is being done by 2 o'clock and then going over to Gatorland and buying hot dogs. And now I rave about Gatorland because it's awesome. Um, so I was, uh, small meetups are cool because it's good to figure out who the audience is. And sometimes you don't know. And also, I can be totally informal. It's not like I'm at a big conference. So I usually just kind of ask people like what they want to learn about because I just smashed a bunch of slides together and I'm going to go through everything super quick until I find the stuff that you guys are interested in and then we can talk about it. But I was hoping to get a sense of what y'all do. Have you heard of ROS? If you're using ROS, what version of ROS? And then, what do you want to learn about? Like basics? Are you guys like actual ROS users who want to know like what's coming down the pipeline? We actually have a release on Monday. And then like what's going on. So I don't know. Usually, so I teach, and so normally we have the kids. The kids never want to be on camera, so we just ask them to put stuff in the chat. But if you guys shout out what you're interested in, I'm curious to hear, and I can see what I can touch on.
Well,
There's
speak for the group. This is Garrett, one of the organizers. I have not heard of ROS. I'm really excited to see what ROS is and how we can use it. So
cool.
I'm on
All
the
right,
earlier side of this. If
cool. All right.
anybody, well, oh, sorry, I'll go ahead and interrupt you one more time. If anybody doesn't have a camera or a microphone and wants to chat, we'll make sure to relay the chat, unless you want to watch it, Cat, as well.
I kind of usually have it down in the corner. I've gotten pretty good at watching it because I do this now like 2 or 3 times a week. All right. So anyway, it was unclear. I just smashed a bunch of slides together so I can hit anything. Feel free to like interrupt me. I'll meander. It's like let's have this be more like it was actually 20 people in a room and not some weird you know teleconference. So basically, why should you care about ROS? And particularly, I'm going to mainly be talking here about ROS 2, which is the new version of ROS that we've been working on it for about 2 years. So if you're not aware, ROS stands for Robot Operating System. Um, operating system is kind of a misnomer. It's more of like a layer on top of Ubuntu to build robots. And I harp on like it's a layer on top of Ubuntu and maybe a few other operating systems. That's how you're gonna have the best time. We've kind of already touched on that a little bit. And then the other thing to sort of take home is it's the probably the largest, oldest, fastest growing ecosystem or open source collection of things to build robotics. And it's all free and open source. So it's not like it's some proprietary thing that builds the robot for you. So I'll give you a bit of history, like how we got here. And so sort of like I like to say there's the before times, which was like when I was an undergrad. Um, most robotic stuff was either like Heathcliff robot toys or it was something like Ford doing this massively capital intensive acquisition of robots that did exactly one thing, and they were used for doing repetitive manufacturing tasks and maybe a little bit of science and R&D. And you really didn't see robots out doing much more than that. And because of like that very proprietary or that very like manufacturing oriented nature, everything was kind of proprietary. it was kind of bespoke. You had these like system integrator people that come in and wire up your robot to do what it was supposed to do. These systems weren't really like feedback driven because we didn't have great sensors, and everything kind of ran on Windows 95 and was controlled by a vendor. So then, like, once approximately when I was getting out of college, things started changing. So at my first job, we actually competed in this. There was the DARPA Grand Challenge and the DARPA Urban Challenge, right? And this is the first point for somebody who's like, okay, maybe robots can do some more sophisticated things. So DARPA, if you're not familiar, is basically a research arm of the U.S. military, and they kind of sponsor these big competitions and big research projects. And they're like, well, can we get cars to drive safely around the desert where they're not going to hit anything and go over this, like, I forget how long the track was. I think it was probably like 100 and some miles or something like that. And people actually, by the second one, they actually got some stuff working. And there was sort of like, if you see up here, I think this is an early, I'm not 100% sure. I think this is an early Velodyne on top, but that was one of the inventions. Like LiDAR wasn't really that big of a thing until the early 2000s. And so LiDAR is one of the enabling technologies that made these things possible. So roughly about that time, you also have all these like companies in Silicon Valley having IPOs. There's a lot of money floating around. People are sort of like leaving their IPO companies, starting new things, trying to figure out what they want to do with all that money. And all these things are kind of in a pot in Silicon Valley, right? So there's like these new sort of like, oh, we can do all this cool stuff with robots. We have a bunch of money floating around. And this is also sort of the Web 2.0 era where people start using open source software to build websites. And so all these things are kind of stewing around in a pot. And, you know, out of this pot comes this organization called Willow Garage in 2007. And basically the whole premise there was, hey, can we do free and open source software, kind of like, I don't know, the Linux kernel or, you know, some of the larger web frameworks or some of the database technologies. Can we build open source that'll allow robots to happen? And so you get Willow Garage, you get a couple of cool robots that come out of it. This is a PR2 robot. And this organization basically helps along 3 open source projects. There's OpenCV, which you may be familiar with. There's a project called ROS, and then there was a third one called PCL, which is Point Cloud Library. Skip the slide. Okay, there we go. And so out of that, they also built 2 robots. They built like the super low cost, I should actually put a picture here, but they built a super low cost tiny robot that you could drop into a room full of graduate students and say like, oh, well here, do you want to learn how to do mapping and navigation and all of these basic robot things? So they built a platform for that. And then they built like the really expensive, really, really fancy platform called PR2 to sort of like, well, what happens if you have a mobile arm on a mobile base with some like very nice cameras? Can you actually start doing more complex robotics tasks in like what we call in the business unstructured environments? And so this software and these robots sort of like started to spread all over the world, mainly in a research community, but people were like, hey, we did some research over here, and that graduate student would get a postdoc over on another continent or across the country, and they would start using ROS to do stuff, and it sort of spread and spread and spread. And so that kind of forced the software development to focus on like, well, how do we manage this huge global community of software developers all roughly working on the same sorts of things. And so there basically ends up being this sort of, you know, there's like the Zen of Python. If there's a Zen of ROS, it roughly breaks down to this, right? That it's a organization that's doing federation over centralization. I mean, federation meaning like, oh, we're lots of small groups and each small group kind of does its own thing, but we all work together, versus having like one central entity controlling everything. Everyone's sort of building small, simple, and the key one here is composable utilities. Don't reinvent the wheel. So like if somebody's already built a good version of something, just make it open source and let somebody else, you know, and then somebody else can use it. Don't keep rewriting the same robotics tools over and over and over again. This fourth one, I think is really important, but a lot of people miss. So it's non-exclusive. That means like a lot of the build tools ROS uses are polyglot. You can use, you know, people have hooks now for Rust and JavaScript and Java, and then generally most things are written in C++ and Python. but there's packaging infrastructure that allow you to sort of build code in whatever language you're happiest with. And then there's inclusive. And this is another one that I don't think people understand about ROS really well. ROS can be used in addition to just about any proprietary piece of hardware or software. It's not like you make the choice of using ROS and then using something else. You really can use a little bit of column A and a little bit of column A. And then the last one is freedom, basically non-restrictive software licenses. Then in about 2013, Willow Garage, the sort of startup money dried up. The organization shut down, and out of the ashes of those organizations came two new organizations. The one I work for, Open Robotics, and then a second one called ROS Industrial, which is sort of based out of Southwest Research Institute. And they sort of, the relationship here is that Open Robotics sort of builds the core source code, and ROS Industrial sort of works on the manufacturing applications that are sort of downstream of these core innovations. So anyway, we've been at this for, a while. And in terms of ROS 1, we are at the final, I don't have a count here, like 1, 2, 3, 4, 5, 6, what is it, 12th, 13th ROS 1 release, ROS Noetic Ninjamis. And this is the last ROS 1 release, but it'll be supported until May 2025. Right now we recommend, and Kinetic is actually, this is outdated. Kinetic is no longer supported. It went end of life like 2 weeks ago. So right now there are two active ROS 1 distros, Melodic and Noetic. If you're starting something new, I'd highly recommend either Noetic or ROS 2 Foxy to get started. And then people, I tell this story and then people are like, oh, it just sounds like a bunch of researchers are doing all of this stuff. Realistically, this is the big sell about why you should use ROS. This is the social proof. On the left, I have the ROS 2 Technical Steering Committee. So these are the organizations that basically fund and support the development of ROS. And then in the center, I have the ROS Industrial, I think it's like, they call it a consortium. So the consortium members. So these are all organizations that are using ROS in some degree, whether they're building interfaces for their hardware or building applications on top of ROS. And then finally on the right, list of government organizations that are also using ROS for research. NASA, recently NASA Viper has come out and said, hey, we're using ROS for some of the ground-based, not ground-based processing of data, not the actual moon rover, but some of the ground-based processing. I'm working on a project right now called Karma with the Department of Transportation, which is all about vehicle autonomy. Obviously, DARPA has used ROS in the past. Army, Navy, Air Force, NIST uses it for competition. Dozens of universities. Open Robotics also does a lot of work with the Singapore General Hospital. And the take home here is like, it's not just a research library. It is actually used by a bunch of different organizations. If you are interested in, say, working for one of these places, you can find, if you learn ROS, you might be able to find the right sort of niche inside the company to work for. It's not just a little project. Oops. So anyway, as I said, ROS 1 is sort of winding down. We took after about 10 years of development, we took all the knowledge we had about ROS 1 and said, well, it's time to kind of do some greenfield development, fix all the production things that people had problems with, and build the sort of next generation version of ROS. We are currently at the, sixth version of ROS 2, which is Foxy Fitzroy. You should go give it a shot. We're actually releasing the 7th one on Sunday. It's called ROS Galactic. It's ROS distros are broken down into two kinds. There's what we call LTS, or long-term support. So Foxy is an LTS, so it'll be supported for 5 years. And then there's sort of the intermediate releases, like the next one, that are only supported for a year or two. And they're kind of stepping stones between the long-term releases. It's very, very similar to how like Ubuntu is released. Oops. So like I said, ROS Foxy is the 6th ROS 2 release. It's the first major ROS 2 LTS release. It's going to have 3 years support, so I think it's at 2.5 at this point. And upgrading to the next release should be fairly easy. I think we've gotten most of the big issues rubbed out of ROS 2. One thing that sort of, and I've touched on this a little bit, one thing that confuses people is that there's a lot of versions of ROS floating around. It's just like there's lots of versions of Python running around, mainly because it's being actively developed all the time. Right now, Kinetic just ended, and we're about to sort of end of life dashing, which was the last ROS 2 LTS release. Right now, in terms of active releases that are LTS releases, you have ROS Melodic, which still uses Python 2, so I don't really recommend it, but it's fairly, there's a lot of packages out there for it. A lot of people still use it. And then there's ROS 2 Foxy and ROS 1 Noetic. Realistically, if you're starting a new project, I would start with either Foxy or Noetic at this point. There's also a rolling release, which is where we do all of the dev work now for ROS 2. So if you're more interested in sort of doing bleeding edge software development, you'd go take a look at ROS 2 rolling, which is just sort of our current dev branch at any given moment. Like I said, we got a new one coming out in the next couple days. On Sunday, it'll be released. It is ROS 2 Galactic. This is a non-LTS release. The big changes, there's a difference in the ROS middleware layer, which is basically the transport layer that exists underneath all of ROS. And you can find details. I put a little link in there if you want to get like the current sort of release notes. I don't think you guys are, I haven't covered the big things, so I don't think you guys are super curious in the features. And I already told you Kinetic's done. And another big thing I guess I should mention is that we've just partnered with Canonical. We do generally just now long-term extended support for some of the deprecated ROS versions. So Kinetic just went EOL. We can actually help people still patch Kinetic. And again, getting back to the sort of, well, how many people are actually using ROS? I ran the numbers a couple weeks ago. Between 2019 and 2020, there were actually, and this is just our servers, there were 500 million ROS package downloads just from our servers. That doesn't include our mirrors, doesn't include VMs, doesn't include ROS running in a container. If you do the math, it basically works out that like just in the past year, ROS has grown in terms of downloads just 94%. If you need more metrics that kind of convince you that people are using this all over the place, I know of at least 300 plus companies that are using it, including a bunch of Fortune 50 companies. We have 35,000 users on our Q&A forum, 5,000 people on our regular users forum, over 2,000 repos on GitHub. Our wiki it's coming up on 250,000 visits a month. And then right now, I think we're actually at closer to 8,000 research citations. And you can find all these numbers at metrics.ros.org. I'm going to skip these because I don't think they're relevant. And let's go right here. Does anyone have any questions? I know I'm going through a bunch of stuff that may not be relevant, so let me stop.
I'm kind of curious. So you said upgrading is easy. I'm glad to hear that. I had a not so great experience with Drupal's handling of an end of life situation, and I'm helping others navigate that now. So, assuming you have a working robot and you're in ROS 2 and it's time for ROS 3, that process is not going to be terrible.
Well, I think part of it, with the transition, I think right now in the past 2 years have been particularly rough, right? Because we've sort of forced people to go through like a ROS version, a Python version, a couple of C++ versions, right? So it's been pretty rough for the past few years, and I don't think it's going to be nearly as bad going forward. Generally, we strive to have like API and ABI like compatibility. So, you might have to change a few things here and there when you upgrade like a ROS package, but it really shouldn't be that bad.
That's cool. That's encouraging.
Yeah. So why don't I kind of touched on this. So I'm going to try to explain kind of what's in there at a high level, because I think that's probably more relevant to this audience. So when we talk about like, well, ROS does all these things, so you don't have to reinvent the wheel. It's sort of like, well, what are those things that ROS does and ROS 2 does? So my sort of canonical example of what's going on is that there are 3 key parts to any robot. right? A robot always has like some sort of actuator. So these hands, it's got some sort of sensor, like your eyeballs or your nose or something. And then it's got something wired up in between the two that's making sense of input data and then doing something with it. That's your basic, simple robot. So what ROS has is it's basically got a set of process encapsulations that are language, I don't want to say language agnostic, but you should be able to, at least in C++, Python, and a few others, be able to write a process that encapsulates one of these aspects, right? Whether it's being a sensor, right? Like I have a camera, I just want to pull images off a camera. Or I have an actuator, I want to make something move left, right, up, down, on, off. And then you have some sort of control. I want to take information from this sensor and then tell this actuator to do something. So ROS has got basically a way to encapsulate all of those in a nice, easy way that makes them easy to start, stop, query what they're doing, see what kind of resources they're using, log their status, a bunch of other stuff. And basically, ROS will allow you to put all of these processes into what we call a package and distribute them. So like, Python packaging is generally more about libraries. I would say like ROS packages are more about executables and packaging up individual units of executable code and the messages that that code uses, and then distributing them. And so there's a lot of basically multi-process control in ROS. Generally, it's C++ and Python, but people do stuff in Rust and JavaScript and Java with hardware interfaces where each of these programs are highly configurable and like may have like variable flow control, like saying, oh, I want to like wire this sensor up to this actuator. No, I want to actually change it and wire it up to this actuator. They're composable. And ROS basically has a bunch of stuff in there to build the shell scripts that would make this possible, right? So an example would be if each of these are an individual process that you need to configure and then start, there's tools in ROS that basically, it's called a launch file, right? It'll help you start each of these things concurrently and wire them up correctly. The next thing, and probably the most important thing to understand about ROS, is that these ROS nodes communicate to each other over something called topics. If you've ever dealt with like RabbitMQ or ZeroMQ or any of these sort of message passing libraries, it's very, very similar. It's just a pub sub bus where you can move messages of a standard type, which means standard serialization type, between these nodes. So when you say compile all these different processes, right, you can compile, ROS will basically has a build system that says, okay, here is a message called images. Now all three of these processes know what an image looks like and how to serialize it and how to deserialize it. And basically the phone number or the topic, as we call it, that these messages are going to be passed through. So in summary, what's going on? Pub sub bus, message serialization, deserialization, and automatically, compiling your code and linking it to the correct message serialization, deserialization formats. That's the big one. So it seems very simple initially, but what this allows you to do is build these huge robots that all use standard messages. And even more important, most of these messages have been already designed and built by somebody else. So you don't really have to think about like, what does a good joystick message look like? Or what does a good image message look like? Or what is a, let's say you have a LiDAR, what is a good like laser scan of a LiDAR? What kind of message would I write? Most of that's already baked into ROS and there's already tools for dealing with it. And what's cool about having these standard messages is it allows you to kind of have things be plug and play. It allows all of these modules to be loosely coupled. So basically one person on one side of the globe can build one thing, another person on the other side of the globe can build another thing, and then they can trade their bits and they're loosely coupled, which is which makes it easy to compose these two things together. Another cool thing about all these is that we've already baked in a bunch of like introspection tools. So for example, if you had this image topic, what you can do using the ROS command line interface is, hey, this sensor is talking to this control node. Let me tap in and see what images are coming down the stream and like, take a look at how fast they're running, take a look at how the standard deviation of the frequency of the images are coming through the bus. There's even like in ROS2, there's QoS capabilities. So you can say like, oh, well, if I'm on a limited like a constrained connection, like a poor Wi-Fi connection, delegate higher responsibility for these messages than say some other message. All of this is sort of, and I'm not going to touch on this too much, but underlying ROS2 is this system called DDS. It's called Data Distribution Service. DDS it's a standard, and there's basically vendors that implement that standard that can then be used in ROS. And so it's a big sort of abstraction layer, but at the end of the day, it allows you to have a very flexible way of moving data around a system, whether that system looks like, oh, everything's running on one computer with everything wired up to it, or multiple computers spread out all across, like, say, the back end of a car or a larger device. So once you have standard messages and a way to move them around, what kind of comes next are standard tools to visualize all of that data. So this is the slide where I basically put all the sexy plots, but we've already built in ROS and ROS2 all of the tools for you to see what's going on. So like there's standard map formats. This is probably like a standard laser scan where everything's getting co-registered and you can actually see the position of things in the room. And then on top of all this, you can annotate everything, right? So, if you're trying to build data sets on top of this, it could be a very, very helpful tool. Another very, very, very powerful, but very, very simple aspect of ROS is something we call bagging. And basically bagging means, hey, we have a standard serialization format for all of these messages. Let's just dump it to file. And this dump to file capability is amazing. It's like having an airplane black box on a robot. So you can just say, hey, robot's running, drop everything into a bag file. And then when something screws up, just go look into the black box and understand why the robot blew up. Bagging is just generally good for doing things like logging, machine learning, and then debug and failure analysis. You can also grab these bags and drop them into your unit tests. So it makes it actually possible to write testable code for your robot with hardware in the loop. You can, send them to collaborators and say, oh, hey, here's what my sensor data looks like. Can you build me a ROS node that can take this in and do such and such with it? You can use the bags to go build your machine learning, deep learning, computer vision training set. And then you can do all the black box stuff that I said earlier. So it's all built. This is all just baked into ROS. Don't take my word for it. Ford is using it for their autonomous vehicle data sets. ETH Zurich uses it for some of their data sets. It's kind of slowly becoming almost a de facto standard for data collection at this point for anything with robotics and sensors. So now that we've talked about nodes, we've talked about topics, the next sort of level up from ROS is ROS's APIs for building both synchronous APIs and asynchronous APIs. So in ROS, we call a synchronous API a service, meaning hey, I want to tell the robot to do something, one node wants to tell another node to do something, and then it'll wait politely while that node does that thing and then calls back to it and says, hey, I did your thing. Asynchronous behaviors in ROS are called actions, right? So in an asynchronous behavior, what you're going to do is you're going to, hey, this sensor, or let's say the brain here, requests that the actuator does something. Actuator says, okay, I'll call you back when that's done. It does the thing. It sends update messages. There's basically an API to write the updates. And then when it's finally done, it says, cool, I did your thing. And this asynchronous API allows you to do preemption as well. So you can say, oh, that thing I told you to do, forget about it. Something screwed up. And so these are all APIs that are baked into ROS, and they're standard messages there's not standard messages, they're sort of standard messaging tools to build them. And having that sort of standard tooling and standard interface allows you to build fairly robust APIs for higher level robot behaviors. The way I like to think about these is like you build, if you have a robot, right, you might actually that example, right, where we were talking about the four-legged robot dancing, you build like say a service to do one little dance, and then you do another little part of the dance, and then you do like I don't know, the butt wiggle at the end or something. And so you have like this thing, and this thing, and then you might build a bigger asynchronous API that says, do the Macarena by composing these smaller service calls underneath of it. Other cool stuff. One thing people struggle with is generally what I call hard math, which is, hey, I have this big robot, it's got geometry, and it exists in a world where I want to understand where things are. ROS has got basically a bunch of tools to understand the robot's geometry. So in ROS, you plug in what's called an URDIF file, URDF, which, depending on who you ask, means universal, or let's just say universal robot description format. So it's basically the 3D geometry of your robot. And then as the axes move, what it'll do is it can basically do all of the kinetic equations. So you can say, hey, here's my frame of reference. I want to know where my hand is with respect to my sort of coordinate frame. Or like, what is the distance between point A to point B? The TF library basically is a standard library for all of those sort of mathematical calculations and a whole lot more. And this is the same thing. Basically, yeah, URDIF defines 3D geometry of your robot, and what you can do is you can just export it from a number of CAD programs and drop it in the robot. You'll also be able to, once you create an URDIF, create a small simulation of the robot, so you can kind of get a sense of what it's doing while it's doing it. And then there's also TF, right? So TF2, which is TF stands for transform. It's basically an API driven, it's an API for, hey, I want to know the position of this, given that I rotated this joint this much and this joint this much, and then move this linear joint here. What is now the position of my hand? So we're moving out of like ROS core into some of our sort of federation or friend libraries that work with ROS. The other thing that you don't have to worry about with ROS is, like, say, if you have a 4, 5, 6, 7 axis arm or some other sort of robot, and you need an inverse kinematic solver. So what is inverse kinematics? It's like, I have a thing I want to pick up, I put the thing over there, and I want to know how to rotate all the joints to get to the thing that I want to pick up. It's fairly complex math problems. There's lots of different ways to do it. ROS actually has a set of tools that allow you to set all of this up. Another recent addition to ROS is, it's called, well, the big one is called Nav2. There's also one called Cartographer, but we have a variety of SLAM and navigation. If you're not familiar, SLAM, it stands for simultaneous localization and mapping. So this is having your robot move around with like generally a depth sensor, but sometimes like a LiDAR, and having it build up a map of a room and then be able to plan how to get from point A to point B. So these are just packages in ROS. I won't say they will work amazing out of the box. You got to do a bit of tuning and set it up for your robot's geometry. But all of these sort of tools for building these maps and then using them is already baked in. Finally, and I touched a little bit of this in when we started, we have a sister library. It's called Ignition Gazebo. One thing that you'll learn when you build a robot is that it kind of sucks to work on a robot, because you actually have to be in front of the robot and you have to wait for it to do stuff. And you're a software engineer and you're used to the things that you tell the computer to do to happen basically instantly. And it sucks when you have a robot and it runs out of batteries or crashes in a wall and you can't have that sort of instant gratification with software engineering. So what most roboticists do is they use they call it a simulator, but it's basically a fancy game engine with physics. And you basically create a fake simulated robot in your simulation environment, and then you do all your algorithm development from there. So ROS works sort of natively with Ignition, but there's more than one simulator in case you have like some other constraints about how you want to do simulation. But these are all sort of baked into ROS. And the other cool thing about this, it means that you don't actually need a robot to learn how to use ROS. You can do it all in your browser, or on your computer without a robot sitting there. Oh, how are we doing here? 17. Okay. Share. I mean, and feel free to interrupt me. I hope I'm not being too boring. So anyway, like I said slightly earlier, ROS is basically broken into packages. A ROS package is very analogous to a Python package, except it's sort of more focused not just on, say, library code, but library code and executables and messages. There are tons and tons of ROS packages, some of them written in C++, some of them written in Python, and a lot of them aren't actually written by us at Open Robotics. They're just written from people trying to solve their problems, or individuals who, say, sell hardware. And we basically provide some services such that, a lot of these things, there's a thing called like ROSDAP, where you can pull in all of these different ROS packages basically by running a command line utility. And we're pretty close. We're getting to the point where a lot of this robot hardware is basically plug and play. So like on the left here, I have universal robot arms. I have like a Ouster LiDAR, SICK LiDAR. I think this is an Intel camera. All of these kind of come with ROS drivers at this point. You should be able to take these packages, drop them into your robot's workspace, and start using them right away. Right? Once you drop them in, you'll see a topic called like this camera, and you can actually start looking at the camera data fairly quickly. A new thing in ROS 2 that's evolving, and it's not, one thing I should say about this, it's not like you're running big ROS. It's like there's now a version of ROS that's sort of built for microcontrollers. And so actually, I think I have a board sitting right here. You can basically, this is an ESP32, but you can build your own little ROS node and you can build a tiny ROS device that natively will speak over that ROS sort of pub sub bus. And, it's called micro ROS. And I think it's still fairly nascent. It's still developing, but they've got it running on a ton of smaller dev boards. It really, like before in ROS 1, you had to go like build a serial connection, and it was kind of a pain to go build your own hardware. And the hope here is I think it should get very, very easy, very, very quickly to start building more and more like simple ROS components or simple ROS robots that can then interface to larger systems. So this is something that's sort of new. I think it's worth looking at a little bit more. This is an IoT meetup, so I don't know how familiar you guys are with sort of hardware systems. But I think it right now supports like 3 or 4 different RTOS versions, like probably 6 to 8 different MCUs. But I'd go look at the MicroROS website and sort of see what's going on. It's like I said, it's fairly new, but I'm super excited by it. It should enable us to do a lot more complex things with ROS in the future. All right, so people often ask me, like, where do I get started? With ROS, point people to like at least the best resources we have. We have ros.org. It's sort of the top level domain. The website's a little old. It's getting fixed right now. New one should be live fairly soon. I don't think this is probably the best place to start. Best place to start is probably like go lurk on discourse.ros.org. So this is sort of our user forum. This is, and I need to give you a caveat. This is not where you ask questions like, I can't get this thing to compile. This is sort of people talking about their like recent projects or like their recent ROS packages they've built, or like simulation environments they've built and that sort of thing. But it's just sort of the hub of recent ROS news. We also have answers.ros.org, which we actually built a Stack Overflow Q&A site before Stack Overflow exists. And so it still actually exists and predates Stack Overflow. So this is sort of the place we try to direct people to go answer questions. There's a good chance if you have a question, it has already been answered on answers.ros.org, but that's sort of the place where you can get help from somebody who knows what they're doing. And then in terms of documentation, the place to go get good ROS documentation is docs.ros.org. They're either comprehensive tutorials about everything I've just talked about. I know recently I've gone through a couple of videos walking people through. I know people fairly often go and make their own videos walking you through a lot of the demos. It should be fairly straightforward. Let's see, what else is going on? New and noteworthy. We have an annual conference. It's going to be in New Orleans, which I think is driving distance for y'all this year. It's October 21st to the 23rd. And it will actually, we are planning for it to be in person unless something drastic happens in the next couple weeks. We also had a developers conference in 2020. It wasn't quite as big and fancy as we normally do. But you should go check it out. All of the conferences we do, everything's recorded. Those videos are free. It's a great place to sort of get plugged into learning about ROS. Other stuff going on. If you're a student or know students, there is f110.org. So this is a student-run, basically they take RC cars, they build ROS-based RC cars and race them. It's super cool. It is all student-driven. I'm pretty sure there's at least one university in Florida, but I don't remember which Florida university has a team. It's worth checking out because I think this is like a very accessible way to get a handle on ROS and start building a small robot. I think the build cost on these are, under $1,000 at this point. And what's cool about it in the past year is that the Indianapolis Speedway has decided they're also interested in vehicles racing. And so there will be college teams competing on whatever the next step down is from regular Indy cars. So a lot of these teams have moved over and they're actually taking the software that they're writing for these things and trying to put them on these things. And I think they're going to be driving around Indy in October, right around ROSCON. Other cool stuff that's happened recently, in the next few weeks, there will be DARPA SubT Challenge will be wrapping up. So SubT Challenge is this, and I have to preface this all by saying, I don't speak for DARPA. I just sort of get to attend and look at some of these things. DARPA is its own entity that is distinct from us, but they run these competitions where people bring robots into analog environments for different situations. So the one I went to was, I think they were trying to make an analog to, say, a subway. And it's actually this crazy, creepy, abandoned nuclear power facility, unfinished abandoned nuclear power facility in the Olympic Peninsula. And so what they did is they create these environments where they have to have these robots explore these underground tunnels and find what they call artifacts. And so the artifacts are this is like a heated human dummy that makes noise, and a backpack. I think there was a cell phone, there was a gas leak, and people have to send these robots down alone, and they crawl around in the simulated space and find all of these artifacts, and they score points based on how many artifacts they can find and how quickly they can find them. Super cool. Quick shot of some of the robots that were there. I actually have a fairly exhaustive write-up on all of the robots, all of the teams. Some of them are universities, some of them are businesses. Super cool. Anyway, the finals are coming up fairly soon. I think they're going to do it all virtual because we actually have a simulator for it. And what's cool about this, if you follow this link, you can actually, we have a couple demos of how you can use some of that simulation technology to go build your own virtual robot and learn the basics of ROS. You can give it a try. It's right here on GitHub. So it's just GitHub, OSRF, SubT Hello World. You can kind of see, here's a map of the subterranean area. Here's the larger overview map. Anyway, if you're looking for a place to sort of get started with ROS and see some real deal sort of robot behavior, this is a great place. Other things, if you're interested in vehicle autonomy, we have sort of a sister organization called AutoWare, and they basically take ROS and build out a full vehicle autonomy stack. They just released the 1.0 version of their software built on ROS 2. It is also ISO 2626 certified, which is road vehicle functional safety. So if you're considering building your own autonomous car or autonomous vehicle, you can take a look at AutoWare. They have most of the tools to do that. Along with AutoWare, there is basically DOT Karma, and this is another open source project by the DOT to build vehicle autonomy. And then, but they're more interested in how do we do things like inter-vehicle communication, and traffic shaping and vehicle infrastructure communication. Again, I can't speak for DOT, but it's an open source project. You can go take a look at what they're doing. It's fairly interesting stuff. As I said earlier, NASA has just released some information that the NASA Viper rover, it's ground system. So once it pipes data back to the from the moon to the Earth, a lot of that data will get processed in ROS. So that's worth checking out. I'm hoping there'll be some sort of more open source that comes out of that. Stuff we work on, so Open Robotics actually is working on a layer on top of ROS right now to do robot fleet coordination. So say you have a hospital with lots of different kinds of robots moving around. How do you actually get those robots to communicate and work together to do coordinated tasks in a complex environment? Okay, so that's the new and noteworthy. Hopefully I left enough time for questions, or hopefully covered what people are interested in.
Very cool. This, I don't know if this is relevant at all, but are there any like beginner online courses or step-by-step tutorials that you would recommend for getting started?
The DARPA one is fairly comprehensive. AutoWare has like a 16 or 12 part video series on everything you've ever wanted to know about vehicle autonomy. If you're interested in legged robotics, there are a couple people that have been working on it using ROS. There is actually a whole talk at ROS World. So if you go to ROS World's website and then like scroll through the talks, you should be able to find something. There are people basically building different controllers, different simulations. There's 2, 3, 4 different people just building their own legged robot from scratch. So those are good places. There's the Construct, which is sort of a third party that does tutorials. There's a lot of, and then the docs too. We have what's called Turtle Sim inside of, so if you install Ubuntu, so like say you install 2004 and then go install ROS2 Foxy. Inside of Foxy, there is what's called Turtle Sim, and it comes baked in, and it's basically just a little turtle that crawls on your screen, and you can actually go through and learn all of the basics of ROS. And that's a pretty like low effort, 3 commands to get started way to do it as well.
That's what I'm looking for. We used to run a different turtle program on one of those computers you showed us at the beginning.
That is the genesis of the name.
Thought so. Very cool. Thank you.
Mm-hmm.
Looks like we got a question in the chat from Rod. He's asking, do you know if the drone communities are using ROS?
Yes. You guys can still see my screen. So, why can't I click? So PX4, we are buddies with PX4 and Drone Code, or the Drone Code Foundation. So a lot of the, I know PX4 you can use with simulation. I think, so this isn't my specialty, so I might screw up here a little bit, but generally there is a bridge to the PX4 drivers. I'm going to butcher this, right? But yeah, there's basically an overlap between PX4 and ROS. Trying to pull this up. PX4 is actually having their big developer summit, and I think some of the PX4 people are doing like a chat tomorrow about it. But I think they're the ones who are doing it every day. I think they'd have a better idea of how to get started with that. And basically, right, they have their own flight controllers, and then sort of what happens is that you can build on those flight controllers if you want to do perception or more complex navigation tasks. Nothing else.
Okay, let's get back to a quick start. So Is there an ISO, by the way, file I could just download that has a full package of ROS with an OS, etc., all installed? It makes life easier.
Well, generally people, so we as Open Robotics don't necessarily distribute the Docker containers, but you can go, I mean, there are Docker containers with everything all ready to go that you can go run. AutoWare uses a similar sort of like a juiced up one they call ADE. I would definitely, like, in the hierarchy of ways to run and use ROS, like install Ubuntu and run on Ubuntu natively, or I would then recommend, like, if that's not a possibility, either do it inside of a VM or perhaps use like a Docker container.
Okay. Cool.
Yeah, and generally what you want to do if you want to start with ROS 2 is, there's a full suite of tutorials here, right? Starting from installation, like, and once you get a Docker container with Ubuntu, like, you can just get a vanilla Ubuntu Docker container, install ROS directly. I mean, it should be about 4 lines to install ROS desktop from apt, and from there you should be able to run all the turtle sims and work through most of the tutorials. Those are all baked in on the desktop version.
Gotcha. Cool. Yeah, I think the mistake or the problem I had the last time was I needed it to run on a small machine. So I picked all of the small devices that I could find first, Raspberry Pis, Mini ITX, etc. Because my experiment was going to be on a Roomba initially. So maybe I just need to suck it up and go learn on a desktop and then start porting to something smaller.
Yeah, it is good to build on a robot. I mean, were you working with like a Roomba or like a Create?
This was actually going to be on a Roomba, yes, initially. Just because I had a couple of them laying around and thought, hey, cool robotics platform for now. So,
yeah, the Create seems to be like former, like Turtlebots. So we do. Oops, wrong domain. So we make a robot called the Turtlebot. Or we don't actually, we license sort of the ROS name to go with Turtlebot, but this is sort of if you want a small robotic platform to get started on, this is a good place to start. We're on the third generation of Turtlebot right now.
yes.
And it does run on a Raspberry Pi now. And this, it's a little platform. It's not, I think you might be able to get a depth camera on there and do slightly more sophisticated thing, but it's, basics of mapping and SLAM and autonomy are all capable on a Turtlebot. And it's a fun little platform to get started with.
I have seen that, yes. Cool. It's been over a year. I've got to go relearn everything or reread everything I did a while back. So.
Hey, we have another question in the chat from Rod. Are FPGAs being used in the robotics space, or is that overkill?
Well, it's a poorly defined question. It's like, yes, depends. Like, what do you want me to say? Like, if you want an FPGA to do certain things, like if you have like high, you want to do some really crazy high-speed vision or like real-time, like very, very fast real-time control algorithms, sure, you can use an FPGA. It's not something we see often. There is a new acceleration group that might be working on some of that, but it's still kind of early for ROS. People do work with FPGAs.
All right. Well, I guess I guess we're out of questions. Kat, this was great. Thank you so much for coming out and speaking to us.